This is ProjMo example video 3, still horizontal motion. Brenna can throw a fastball like nobody's business. She can throw a ball at 41 meters per second to someone that is 25 meters away. How far down will it have fallen during that time, assuming she threw it completely horizontally? So this is Brenna, and she's throwing the ball. It's going like this, but it's also going downwards. And the question is, how far downwards? So mapping it out, this is the displacement on the x, and then we have the displacement on the y, and it is, of course, going downwards because the acceleration due to gravity. And we have we have the initial velocity at which she was throwing. That's on the x-axis. Now we can go ahead and make our list of variables as before. On the y, I have my initial, final, acceleration, displacement, and time. The initial velocity on the y-axis is, as before, 0. Final velocity, we're not so interested in. Acceleration is equal to little g, which is also equal to negative 9.8 meters per second squared. Displacement, I don't know. This is what I'm looking for. And I also don't know my time. So that means I need to move on to my x-axis. My x, I have velocity on the x, displacement on the x, and then the total time. For my velocity on the x, that is given as 41 meters per second. My displacement on the x is given as 25 meters, and the time is unknown. This is ideally pretty easy to see, that dx equals vx times t. Solving for t, I've got my dx divided by my vx, my displacement divided by velocity. So that ends up being 25 meters divided by 41 meters per second. Tap that into my calculator and I get my time is 0.6098 seconds. That is my time, which is the same as this time. So that means I now know my everything for the y-axis except my displacement, and I don't care about my final. So that means not caring about final, d equals vit plus 1/2 at squared. Once again, that's 0. And that means I've already rearranged the equation, all I need to, because I'm solving for displacement. So d equals 1/2 negative 9.8 meters per second squared times the time I had just solved for, that was 0.6098 seconds. That is all squared. Tapping that into my calculator, I get the displacement on the y-axis is negative, because it is going downward, 2.988 meters, or with reasonable significant digits, I'd say d is negative 3.0 meters. Now, is that reasonable? No. 3 meters is at least 1.5 times the size of the average person. So that is why when most people throw a ball, instead of throwing it across like this, they're actually throwing it at an angle. But hopefully that gets the point across to us.